So on to another graph of an inequality. With this particular example, I'm going to want to recognize what type of curve I have. So the first thing I always do is I replace my inequality symbol with an equal sign so I can get a better idea. So I'll rewrite. I have x minus 3 squared over 36 plus y plus 1 squared over 16 equals 1. And that kind of reminds me of a conic section. I have a plus sign. Both of the variables are squared. So I do have myself an ellipse. And I just pay attention to the fact that there is a larger number under the x term. So that, in fact, gives me a horizontal ellipse, which means we are wider in the horizontal direction. That's probably not the best ellipse, but you get the idea. So then I kind of just go back and say, okay, I do remember a little bit with ellipse. I would look for where the center is located. So my center is always HK, and that always assumes with whatever term is kind of by the x or the -3. So opposite of what you see, the center would be 3 and -1. So I'll plot that. 1, 2, 3, and -1. There's my center. And then if I'm going to figure out, the main portions to help me out with the graph, I'll figure out where my vertices are and my co-vertices. So because we have a horizontal ellipse, I'm looking at who A and B are. In this case, my A is the larger number, or A squared is a larger number. So A squared is 36, which means A will be 6. So that's helping me understand that I'm going to count 6 units out from the center, left and right. So 1, 2, 3, 4, 5, 6. There's one vertice. And one more. 1, 2, 3, 4, 5, 6. There's another vertice. So I'm almost there. Next thing would be to get where our B squared term is. So B squared is 16. That gives us B equals 4. So that would mean I count up and down from the center 4 units. So 1, 2, 3, 4. There's a co-vertice. And another one. 1, 2, 3, 4. Another co-vertice. So this is going to give us our guide points for our ellipse. The last thing we want to double check is, should we have a dashed or solid curve when we draw this? And so notice we do have a less than or equal to. So whenever you have a less than or equal to, we will be looking at making a solid curve for this graph. So I will do the best I can, drawing the best ellipse freehand. Sometimes it may take a couple of tries. But for the most part, that's a pretty accurate graph. I don't think it's that pretty, but I can tell it's an attempt to make an ellipse. Pretty cool, right? So remember, one last thing is we are solving and graphing an inequality. So the next thing you'd have to do is figure out where you're going to shade. So you have 2 choices. You're either going to shade inside the ellipse or outside the ellipse. And if you have a pattern down, great. But I would like to use a test point. And so with my test point, you kind of notice there's popular. It looks like the ellipse is not going through 0, 0. So that's what I'll test. And if I were to plug this into my inequality, I'm substituting in for x. I'm going to write everything out and just kind of show you where I'm plugging in numbers for x and y. I saw the less than or equal to 1. Remember, it's a question. We don't know yet. So if x is 0 and y is 0, we have both zeros in. So all we have to do is kind of play around. What do I have? -3 squared, that's positive 9 over 36, plus 1 over 16. And if you feel like it, we're just trying to say, hey, is this less than 1? We can play with a little bit of estimating. Like I know that 9/36 is less than 1/2, and so is 1/16. It's also less than 1/2. So if you add them, you should still be less than 1. So I am getting a true statement. So that's if you're kind of like already playing around with your numbers. Or you could pull up your TI, feel free, and you just kind of say, what's 9/36 plus 1/16? And then we do get, we don't have to worry about whether it's a nice fraction or not. We just get 0.3125, and for sure, it is less than or equal to 1. So still true. So whatever helps you out on that. So if you're getting a true statement, what does that mean? We're going to shade the region that contains our test point. So that is inside the ellipse. So there's my shading. And we have just graphed our inequality. I'll see you in the next example.